What's up, everyone? Like we said, today we're talking kind of about the dirty secret of air travel. Something that I don't think is publicized enough is the challenge that we experience from an environmental perspective when it comes to short haul flights. They're huge environmental villains. Traditional short haul flights are really inefficient, and as a result of that, their energy consumption being really inefficient, they're super like awful for the environment. They're even becoming illegal in a bunch of European countries. They've started to realize the environmental impact of this. Um, and I think like France is an example, and maybe Spain was another one that are starting to regulate against short haul flights. So this kind of sets the scene for us. But if you're a jet setter, you love traveling around, you love your short haul flights, you have a little bit of relief. We were talking about this team from DLR, which is the German Aerospace Center, and they're creating a hybrid short haul plane that relies on both uh, jet propulsion as well as electronic propulsion using electric motors
hmm
to overhaul the short haul flights, more green technology, redefining the segment, and hopefully providing an alternative to these like pretty awful short haul flights for the environment.
Yeah. And this one has a great story behind it. So you're talking about DLR, the German Aerospace Center. But before these folks came up with the idea to do this, there was a joint effort between NASA and DLR to come up with a prototype that could meet this challenge, right? Like you said, regional aircraft, they can be pretty big pollutants. There's all these efforts to potentially phase them out or replace them with something more sustainable. And these two big organizations were like, what if we just open this up to our best and brightest that are currently in school and just kind of let them go nuts? Let them pitch us what their vision of this looks like. So that's exactly what happened in 2019. They hosted this competition. Students submitted their ideas, and I believe it was students at the University of Stuttgart that had the winning proposal, and their system was called the HyBird plane, which amazing when you
Yeah,
realize the fact that
you
it's a
know,
hybrid plane.
we
Uh,
like to provide our unsolicited commentary on how well projects are named while we're on this podcast. I would give this one like a solid 8.7.
I was gonna say 8 out of 10. This is a good one. But yeah, so that's what happened. These students they made this proposal. The proposal won. As a part of their winning package, DLR offered them jobs to come on board and actually spend time developing this project, which is probably one of the coolest prizes ever, right? Like you get to pitch your dream and then you work on it to become a reality. But just like you said, they're going after short form regional flights. This prototype, this proposal that they submitted and won was for a 9-seater configuration. This was, by the way, the requirements of the challenge. It had to be a 9-seater plane. It needed to be reconfigured easily for cargo. So in case it's not going to be used for hauling passengers, but rather cargo from point A to point B. It needed to have short takeoff and landing, and it needed to have some level of autonomous capabilities. And of course, to be sustainable, you have to take into account, if it's going to be fully electric, hybrid, or whatever. And again, as the name suggests, this was the hybrid solution that won. So, fun little background on what's going on here.
Well, and I think just some context, right, to try and understand why exactly it is that short haul flights are so much worse for the environment than
Mm-hmm.
long haul flights. Um, and I guess to set the scene overall, short haul flights are actually becoming more and more popular, despite the fact that legislation is trying to direct us away from it. So passengers want more and more short distance air travel for areas, especially with like lower passenger numbers as they start to get connected to these flight networks. Um, People outside of these like main huge international hubs, people in the more regional airports, they're starting to become more accustomed to air travel. They want more. There's increasing demand for these short haul flights, but they account for almost a third of the aviation industry's total global greenhouse gas emissions. This includes even manufacturing of the airplanes, like the entire scope of the aviation industry. Short haul flights are the biggest offender in that entire category, and it accounts for over a third of the aviation industry's global emissions. Short haul flights are about 30% worse per kilometer in terms of grams of CO2 emitted as opposed to long haul flights. And that disparity is mainly due to the fact that there's really, really high fuel consumption during takeoff and during
Right.
landing. So if you were to like smooth out the average consumption um, of a flight where the takeoff and the landing was say like 25% of the miles that you flew were this like super high consumption takeoff and landing, um, you would have much higher total emissions over or average emissions over the length of that flight. So the level flight segment is actually not something that we're super concerned about. It's the takeoff and landing that are the ones that are huge offenders from an environmental perspective. And I think that's important to understand because that directly fed into how they attacked this problem with the HyBird electric concept. Um, One of the things they wanted to make sure was that they could have a system that scaled up appropriately to be able to like basically address the high energy demand during takeoff and landing, but then also could turn down and become more efficient for the level flight segment. And I think the HyBird team from Stuttgart, they addressed that exactly.
Yeah. And do you want to hop into the secret sauce of how they accomplished what they accomplished?
Let's say that like this is just one part of the secret sauce, but they've
Okay.
got a hybrid propulsion system at a high level, 2 gas turbines that are generating electric power,
Mm-hmm.
and then I think there was 4 electric
Yep.
propellers. Is that
Four.
true?
Four.
One
Yeah.
at the end of each wing
Yep.
tip, and then both tips of the V tail at the rear of the airplane. They've got 4 electric motors, 2 gas turbines. The 2 gas turbines, they use both of them during these high energy demand, like during takeoff. They are able to turn on both gas turbines to generate enough electric power for the demand of this takeoff. But then they're able to switch off one of those turbines during cruise to save energy to be more efficient. And I think that that's something that um, we don't traditionally see this in our um, gas powered jets today. Is that they might reduce the thrust on these motors, but you're not able to completely shut off half the system, at least to my understanding, to try and save energy. And I think between that and the fact that traditionally during takeoff and landing you have to consume a lot of jet fuel to keep up, um, electric motors are actually really really good at generating a lot of torque at low speeds, and that's something that I think provides a competitive advantage for this HyBird team versus someone who is trying to make a more efficient jet without using electric propulsion.
Absolutely. And to kind of add on to that, the benefits of the propulsion system, right? I want to talk about a common theme that we've discussed when it comes to electric flight, and that's weight, right? Like there's been this huge issue of what kind of energy storage method are we going to use for electric flight? Is it going to be batteries? Well, batteries are heavy. And as you use them, not unlike fuel, like you can't just lose weight. They're just dead weight at that point. And now it's more of a burden for you to keep on flying. Well, with this hybrid approach, like you still have fuel tanks that the turbines up front will use to generate that electricity, and relatively smaller batteries that are helping support those motors at each wingtip, right? So that's a pretty like smart way of making sure that you're saving weight while still leveraging the benefits of electric technology. On the
And
other end,
it's during this takeoff, right, that they're able to leverage extra stored capacity in the batteries, um, to they call it battery boost, right? Battery boost, where they're able to like draw extra energy from the batteries to ensure an all electric takeoff.
yeah, yeah. I was going to say on the other end, you know, if you've been flying for a while, I'm sure you've noticed if you sit next to the wing like I do because that's the best seat. I'm sure you've noticed that wings have like transitioned from having tips that are completely flat to like slightly curved over time, and there's a reason for that. It's mainly because of generated wingtip vortices that create turbulence, and that turbulence results in a less efficient system. Well, over the course of I think the past like 20 years, NASA has actually been testing different tips that can eliminate those vortices. And if I remember correctly, it's like reducing the fuel consumption by 2 to 3%, which is actually like quite substantial when you think about this like very small design change being applied to every plane in the world. Well, the folks here, the reason they came up with a system that has these motors at the tip, where you have turbines spinning at the tip, is because that the generated vortice kind of goes hand in hand with the thrust that you're trying to generate. So it actually kind of helps you out. And you can think of it as increasing how much thrust is being generated or reducing the amount of drag applied to the system. So they've taken this very negative thing and they've turned it into a positive that actually helps with the sustainability of this aircraft.
And just a fun fact on winglets there, that the tips of wings that are curved. Um, when they were originally testing the first concepts of winglets, they tried a bunch of different ones. Some of them actually made the wing performance even worse. But the best winglets on the market, and I think those are ones that like Boeing and Airbus and Embraer use pretty commonly, were shaped after the shape of a shark fin, which is super cool that they ended up in getting a nature inspired solution there that was able to save a significant amount of fuel consumption.
That's pretty cool. Yeah. Well, one more thing I want to note before we move on from this. These students, as a part of their submission, had to develop like a report on their design. Usually, the article is great. The article that we're going to link in the show notes for you to get a little glimpse of what's going on. But if you're really interested in this topic, read the paper. It is one of the most well-written papers I've ever read. Like, even if you don't have a, thorough engineering background, everything is laid out in such a digestible manner. So kudos to the team. And one thing they highlighted, which I think was kind of missed out in the article, is that they actually came up with an algorithm for mass optimization. A couple episodes ago, again, we were talking about electric flight. I think it was from MIT. We were talking about how there's this new motor that's supposed to be great for all things electric flight, and they're coming up with an algorithm to help them, design the system as a whole, not
It's
one
episode
system.
131. If you want to
131.
go back and listen to it.
What is that, like 5 weeks ago at this point?
Yeah.
But this team came up with an algorithm that takes the cruising speed, the wing loading, the power to weight ratio of the turbines up front to guess the maximum takeoff mass, right? And then what you get as the output is the amount of fuel consumption and the required size of the components. And using those two values, it can recalculate the actual maximum takeoff mass, right? So if you've been following those like 2 or 3 steps, you have a guesstimate of what your maximum takeoff mass is going to be, and then what the actual is going to be based on what you put in. And what their algorithm does is that it's an iterative approach of feeding it back into each other until those requirements converge on the final design. And that's what they used to, get the right sizes and everything of the powertrain, of the body, of et cetera, et cetera. And I think that's just super cool.
Well, and let's talk about kind of the so what here, right?
Mm-hmm.
So we've got this awesome team from University of Stuttgart. By the way, that's high praise coming from Verbode, saying that he really, really enjoyed the student paper. We've read now 136 of these papers since doing the podcast, and even more before that. And that's kind of how Verbode and I met, is reading these scientific papers and talking to one another. It's very rare that I ever get a text message from him in the middle of the night saying, "Wow, I just found one of the best written papers I've ever seen." So kudos to the student team from University of Stuttgart. But we've got the student team. They came up with a concept design. They won the NASA challenge in 2019. It's now 3 years later. Why is this got back up on our radar? And I think that's part of the important part to talk about here is they were able to recently create a 1/4 scale demonstrator, which weighed 25 kilograms, and it had its successful maiden flight. It collected valuable data, and they're going to be able to feed that back in to refine the aircraft concept. Not only are they working with DLR, not only are they working with NASA, they also now have a contract they're working with Airbus to help develop this into a real commercial airplane, which, again, if you take this as like a student team in 2019, you've gone from like entering a student competition, which may very well have been like their capstone design paper as a bunch of undergrads. The student team in 2019 has then now worked with NASA, now worked with DLR, now they're working with one of the industry leaders in Airbus to help develop this into a real concept. They've built a 1/4 scale demonstrator. It successfully flew, had its maiden flight. It's really, really impressive, and I would say that these are all indicators that this technology is coming, as opposed to being someone's pipe dream that lives in a scientific paper and sat on the shelf and never actually got any traction in the real world.
Absolutely. And the impact, by the way, in terms of, what would this look like if it was deployed tomorrow, right? Well, their design, the promise is that it can cover a maximum range of 390 nautical miles, which covers about 97% of the US mainland from the 20 biggest airports. And when you're doing like an apples to apples comparison to, current aircrafts, apparently it's going to result in a total 50% cost reduction on all operating costs, which is very impressive.
Incredible.
Not only is it more sustainable, but it's also like half the price. So that's very promising. And one more thing I want to point out here is 2019, when they first did this challenge, NASA and DLR, I think it was their third time doing it. And I guess it was very successful, as we can see. And I think there's a challenge for 2022 that's still live, or 2023 that's still live. I'm not sure. But that challenge is even more ambitious than this one. It's asking for a system that is driven by a completely hydrogen fuel cell system that can carry 136 passengers. So I think we're starting to get into the Airbus 333, or am I mixing up my numbers? Yeah, Boeing 737, Airbus 333, like the small aircrafts that you're probably used to if you're going from state to state. And they're trying to tackle that problem by crowdsourcing it essentially from people that are, willing to go out of the norm. They're not like stuck in this box of thinking of what industry limitations are. And Dan, you and I, we did capstone design projects where like industry partners would come to us and ask us to think outside of the box. This is just my way of like, putting this out there. Do more of that. Like this is great. Crowdsourcing solutions from students, that's such a great idea. It's good for them to learn, and it's good for you to open your mind into what the possibilities can be. And look, sometimes you can get an aircraft that completely meets all your requirements, and maybe even some more than that, just like we're seeing here with the students from Stuttgart.
Yeah, I know. I'm with you, man, and I think the industry needs more of that. It definitely was like an awesome formative experience for you and I during our undergraduate.
Absolutely.
Being able to do some research and development hand in hand with someone in the industry who actually understands the problem, had a little bit of funding from them, so we're actually able to do something in the real world, have some funds to go build something, and then, some of our solutions end up getting adopted into industry. That's even cooler. And this team from University of Stuttgart, they're probably the poster child for this type of arrangement. The fact that, 3 years later, they're still working with people in industry. They've got jobs working on this with people like DLR and Airbus Protospace. It's super interesting. One thing I want to mention is this propulsion system that they designed actually reminds me a lot of the Nissan e-Power hybrid powertrain.
Yes.
Which is something we talked about, like, I think 120 something episodes, episode 9. It's really, really interesting. That was Nissan's bet on how they were going to develop hybrid powertrains. And the idea there is they're not trying to shift back and forth between engine driving the powertrain and electric motors driving the powertrain. Instead, they're using an engine turbine, right? An engine similar to the way that this hybrid team is using the turbines to generate electricity, which that can be used on demand to recharge smaller batteries, so it reduces the weight. And then those smaller batteries are the ones that are passing electric power to the motors to do the actual driving. And I think the Nissan team said that they thought that they could develop a hybrid vehicle with a lower carbon footprint than anyone at either end of the spectrum. So lower carbon footprint than someone who is creating just internal combustion engine vehicles, and lower carbon footprint than someone who's creating fully battery powered electric vehicles. I'm not sure how that's developed. I haven't seen any Nissan e-Power hybrid powertrains on the road, I don't think. But I would be interested in understanding if this team, the HyBird team from University of Stuttgart, if they are also able to achieve something similar where they're actually more efficient than anyone with a fully jet fuel powered plane, and they're more efficient than anyone with a fully electric powered plane, and they've actually kind of done a good job of towing the line between those two technologies.
I'm so happy you brought that up because I had completely forgotten about it. But if I remember correctly, very similarly to what seems to be, DLR's approach, Nissan was saying, hey, like what we see as the sustainable future is fuel cell cars, but the technology is just not there yet. So this hybrid system, this will be like the in the middle solution until we get there. And again, from what we can see from DLR with this challenge that they have for a fully fuel cell powered airplane, it looks like this hybrid system is also supposed to bridge that gap. So that's pretty interesting to see that similarity between two different industries.
Yeah, and I would just say that's a testament to being steeped in the technology, being, keeping up to date with it. And, not that you need this plug if you're already listening to the podcast, but personally, I think that's like a big thing that the podcast has brought to me, right? Being able to stay up to date with all these different technologies, and then being able to make connections across industries.
Absolutely.
And feel literate in these conversations, in areas that I'm not even pedigreed to understand, right? I can now understand the trends in aerospace development, even though my background is in automotive engineering.
Absolutely. Absolutely. I think now is the spot where you should drop a ELI 5 summary of what we just talked about.
All right, so to sum up what we talked about today, we talked about the dirty secret of air travel. Today's short haul flights are actually the real environmental villains, and this team HyBird from the University of Stuttgart stepped up to the challenge to address the status quo here. The current challenges being these traditional short haul flights are way less efficient and even less eco friendly than long haul flights. They're even becoming illegal in a bunch of European countries. But the challenge is a lot of people want more short haul flights. So, how are we going to address this demand? If you're a jet setter, you don't have to worry. DLR's HyBird team is coming to redefine this with green technology. It basically is a bunch of student geniuses from a NASA DLR challenge. They're showcasing their young innovation. They created a hybrid powertrain that uses 2 gas turbines and 4 electric motors to address the inefficiencies of today's flights with a quieter, cheaper, and more sustainable alternative. And I think we're going to see this coming in the future. Their blueprint for transforming regional air travel is something that's been accepted by NASA, by DLR, by Airbus, and they've even started building demonstrators to start testing their technology in the field. So I think it's only a matter of years before we see this, and maybe we're able to hop on a hybrid aircraft to get on a regional flight.
Boom. That was solid. Good job, man.
Thanks, dude.
All right. Everyone, thank you so much for listening. And as always, we'll catch you in the next one.
Peace.